so when doing C3, on the front of our exam paper, there's a number of formulae we're going to write down. So some from C2 that are used again. So let's start this off as sine theta over cos theta is equal to tan theta. And I'm going to write down sine squared theta plus cos squared theta is equal to 1. Now, I'm also going to write down by here cot, cosec, and sec. I'm going to underline the third letter in each of them, which is going to help me with the next bit. So, what I do to this formula is I divide through everything so that I'm going to get, divide through everything by sine squared once and cos squared once, so I get two new formulae that I use for C3. Now I know that sine divided by cos gives tan, so if I do sine squared divided by cos squared, I'll get tan squared. So I'm going to divide through formula number 2 by cos squared. So sine squared divided by cos squared is tan squared. Cos squared divided by cos squared is 1. And 1 divided by cos squared is sec squared. So that's why I wrote that down there. Third letter is the letter it is 1 over. So now I've divided everything by cos squared, so now I'm going to divide everything through by sine squared. So sine squared divided by sine squared is 1. Cos squared divided by sine squared would be 1 over tan. 1 over tan is cot, so it's 1 plus cot squared theta is equal to, and then 1 divided by sine squared would be cosec squared. Okay, the other thing that is absolutely vital that I'll write down is sine theta, cos theta, minus sine theta, minus cos theta. And when we are working down that way, we are differentiating. When we are working up, we're integrating. So there we go. I've got a little formula booklet. You also need to use the formula booklet in this this paper. We've got a little one that we're going to use probably throughout as well. Okay. So question 1. Now some of these things I'm going to go through in detail, and some of them I'm not going to go through in so much detail, purely because I'm on holiday and I want to have a little bit of a break myself as well. So we are doing, what is it, C3 Jan 14. So C3 Jan 14. Okay, now it gives us the formula here, pi and trig straight away, then make sure you're in radians. We need to go and work out h, because we're doing Simpson's rule. So it'll be the limits, you subtract and you divide by the number of strips. Now there's 5 ordinates, so therefore 4 strips. Okay, so I divide that by 4, so therefore h equals pi by 12. What else do I need to do? The rest of it now just goes into my calculator. So I would write in, so like I said, make sure I'm in rad mode, so shift mode and 4, and then mode and 3 to put it into table mode. So f of x is equal to tan squared, so I want to get rid of that. So I want it to be tan squared. So I'm going to put in brackets tan alpha x and then squared outside. Note the bracket around tan. I could write as tan x times by tan x. That would do the same thing. Start is whatever this number here is. So 0 equals, and end is pi divided by, it's better to write it as divided by in this form when you're writing it into the table mode, divided by 3, and my step is pi divided by 12. And I get my table. Now, we write the table out as this: x0, 0, x1, x2, x3, x4. Okay, now, my step is pi by 12, so I'm going to say pi by 12. Now, this would be 2 pi by 12, which you could write as pi by 6. This would be 3 pi by 12, which you could write as pi by 4. And this is 4 pi by 12, which you could write as pi by 3, which was the top limit here. So if you want to, you can write that, but I find it like a more logical process to go through these numbers here personally. So y0, y1, y2, y3, and y4, what do they equal? Probably all ranked numbers, maybe not though. So the first one's 0, the next one is now a long number, it wants it to 4 decimal places, so I go to 2 more and cut off. So 0.0717, so that's 4, and then 9 and 6. The next one is a third, the next one is 1, and the final one is 3. I would now go to the formula booklet to find out this formula. It says h over 3 of y0 plus yn, so in this case it will be y4, plus, let's double check, I think it's plus 4 lots of the odds, so that'll be y1 and y3. Where is it? Simpson's rule. There it is. Okay. Plus 4 lots of the odds and 2 lots of the evens, not including the last term. So that will be plus 4 lots of y1 plus y3, and then plus 2 lots of y2. So h over 3, so that's going to be pi by 12 divided by 3, which would be pi by 36. Then we get y0 plus y4, so that's 3, plus 4 lots of 1 plus that, so that's just going to be 1.071796. Don't normally work out quite as nicely as this. Plus 2 lots of y2, so plus 2/3 then. And that's going to go in my calculator. So take it out of table mode, so modem 1 or shift 93 equals pi by 36, 3 plus 4 lots of 1.071796, and plus 2/3 is that number there. So we got the answer in the previous bit of 0.694124 decimal places, which was that number there. Now, part B, now this is the bit we're likely to find hard. It says, use your answer in part A. So what we've just done, we have to use here to deduce an approximate value for the integral of this thing here. So tan squared and sec squared. Now this is where that thing that we've done at the start is hopefully going to pay off. So I can see there, fact number 3, sec squared is the same thing, is equal to saying tan squared plus 1. So what I need to do, I need to write out for part B, I need to write out that integral. So integral between pi by 3 and 0, they're the same limits as well, so that's good news, of sec squared x dx is equal to the integral of pi by 3 between pi by 3 to 0 of tan squared x plus 1 dx. I'm going to put that in a bracket because there's two things, okay? But that is the same as that. That's what that definition told us from fact 3. I'm now going to split that integral into two things. I'm going to put it into pi by 3 and 0 of tan squared x dx plus the integral of pi by 3 to 0 of 1 dx. It's absolutely fine when you're adding integrals, just split them and do them as two things. If these two things were timesing, as we've seen a lot in C4, we would take it out as a multiply here, but no need this time, okay? Because they're adding, you can just do them as two separate integrals. Now the great news is, this bit here we know was this answer. So I can say that that's 0.6941 plus, and then integrating that, well that's lush, it's just a single number with no power of x. So put the power of x up by 1, is literally just going to be 1x, or just x. So x between the limits of pi by 3 and 0. So I need to do pi by 3 take away 0, so in other words just pi by 3. So that answer from before, if I plus pi by 3, I get my next answer, and I'm going to round that to 4 decimal places because the last one was to 4dp. So 1.7413 to 4 decimal places. Okay? Okay, question 2. Question 2's proof by counterexample. Now these things are normally pretty simple, but I'll show you like an easy mistake to make on this, and I'll try and show you what the logic that you need to use. You may have to use a bit of logic. It says, show by counterexample that the statement, if x is an acute angle, then sine x plus 30 is greater than sine x. So I'm going to let x equal, and the tip I gave you was not to use 30, 45, 60, 90 or 0 because they tend to actually prove the point. So I'm going to let sine equal 1 because that would be an acute angle, wouldn't it? So I've got, what have they got? Sine x plus 30. So that would be sine 1 plus 30. And then I'd find out what that is, and then I need to find just sine x. So sine x would just be sine 1. So I'd have to be back in degrees mode for this because look, it says there degrees, so unless it explicitly states degrees work in radians, but it does explicitly state degrees here. So sine 31 gives me 0.515 blah blah blah, and then sine of 1 gives me 0.017 blah blah blah. Now that's an issue because look, that answer there is bigger than that answer there. So that doesn't help me, that's useless, that's actually proved their point. There you go, there's my two answers there, sorry. So that's actually proved that point, so that's no use to me, okay? Now, you could get yourself into a real faff in this question and think, oh, I'll try 2 and 2 won't work, and it won't work up until quite a large number. So let's just stop a moment and think of what the sine graph looks like. So sine is an S that goes through the origin like that, okay? This value here maxes out at 1 for 90. Okay, now we know that it's got to be an acute angle. So if I take a number just by here, I know it's going to be really large. Let's say 89. Okay, that is an acute angle. If I add 30 onto that, then I'm going to be down here. So then it's going to be less by there. Okay, so that's the best way to do it, or at least that's the best way I think to do it. I think if you use any value up to or down to 75, going up towards 89, it'll work. But I'm going to use 89. So let x equal 89. So then I'm going to get sine 89 plus 30, I'll work out what that is, and then I'll do sine of 89 by here, try and let you see what I'm doing. So sine of 89 plus 30 is 0.8746 blah blah blah, and then sine of 89, pretty close to 1, 0.999 blah blah blah. Okay, so what do they say here? They said that this has to be bigger than that. So that's not true. I'm going to say as 0.874 blah blah is less than 0.999. It follows that, and I like to write in what they had originally. So sine x plus 30 is less than sine x in this case. Maybe not always. In fact, I proved a point above where it's not always. I'm going to say in this case. Therefore, by counterexample, I have proved this to be false. Okay. Part B. This might be one that I'm not actually going to go through. I think you're pretty good at these, to be fair. You're very good in C2, so I'll get you started off. But who knows, I might get really into it and think, oh, I'll just finish it off anyway. So, we're looking for the non-quadratic, which is the cot. Everything's got to be in terms of cot. So I need to go and turn my page over. The one with cot. Then now I haven't actually got that in terms of cot. So this is my fifth one that I can generate if I want to. So cot squared theta would be cosec squared theta, and take the 1 over, so it'd be minus 1. So wherever I see, that's not what I want to do. That's a lie. I want to have everything to have cot in it. So wherever I see a cosec, I need to change it to 1 plus cot squared theta. Okay? So cosec change to 1 plus cot squared theta. Let's just check this right. Yeah, 1 plus cot squared theta. But I could have had it come round the other way as well. So 15, so 1 plus cot squared theta plus 2 cot theta, and I'm going to bring that 23 over straight away as well, so minus 23 equals 0. Expand out and collect the like terms. I'll try and do it really quickly. 15 cot squared theta plus 2 cot theta. I'm going to get plus 15, but then take away 23 is minus 8 equals 0. I'd then factorise, like I've done all the C1 and C2, so that would be what, minus 120 and plus 2. So a pair of numbers to do that are 12 and minus 10. So factorise 2, 15 cot theta plus 12, 15 cot theta minus 10 equals 0, but then you must cancel down, so we get what, 5 cot theta plus 4, and here we just get 3 cot theta minus 2 equals 0, so cot theta equals minus 4/5, or cot theta equals 2/3. Change now, third letter t, tan, so 1 over, so I'm going to do the reciprocal now, so tan theta would equal minus 5/4, tan theta would equal 3/2, and I will find the answers just because tan's quite easy because of the fact that it repeats every 180 degrees. So I'm not going to do all silly tomcats here. I'm literally just going to run through really obviously take the tan over to the other side. So tan minus 1 of minus 4/5. And the first answer is negative 51. Now, if we just look at the answer, it wants it between 0 and 360, so that's no use to me. So literally all I do is say answer plus 180. So first answer, 128.7. And then press equals again, I've got a next one. The next one clearly will be over 360. And then here, I'm going to do tan theta, 3 divided by 2, which is 56.3. And then plus 180 again, 236.3. Now there's a way you can check this if you wanted to. It's not quite as easy as it was in C2. But cosec means 1 over the third letter, which would be sine squared. So I'd write this in as 15, and then sine ans, but then I need that to be squared, don't I? Because it's cosec squared. So I'd bracket all of that and square by here, and then plus 2 over cot, so third letter is tan, so tan ans. Now I'm hoping that this is going to give 23, because that's what it should do. But if I'm wrong, I'm going to feel like an idiot. There we go, it's 23. Now I'm leaving that exam knowing I have those 6 marks. I cannot possibly not have those 6 marks, and it's a very nice feeling in the exam knowing that you've got those, trust me. Okay, now the next one, implicit differentiation. Watch out, they're going to expect you to do a little bit of C3 work here. In terms of the differentiation, okay? So we've got x cubed minus 2x squared y plus 3y squared equals 3, okay? So I'm going to differentiate that through implicit differentiation. So whenever I see a y, I just differentiate it like I normally would, but then I have to put a dy by dx with it. But also here, I've got a product rule, because I've got these 2 letters timesing together. So here, I'm going to note that I have u dot v straight away. So u, now I always include this sign here and make your life a million times easier. You don't have to, but it's a bit harder to work out what you're doing. So u is minus 2x squared, v is y. U dash would be minus 4x, and v dash would just be 1, but then times by dy by dx. So what we tend to say when you're in good practice is just dy by dx. Okay, so let's go through differentiate that thing now. So that would differentiate to 3x squared, and then it's going to be u v dash plus v u dash. So I'm going to get minus 2x squared, and then times by dy by dx, and then I'm going to get plus minus 4x times by y, plus 6y. Now, whenever you differentiate a y, you have to put a bracket dy by dx after it, equals, and then 3 differentiated is just 0. Okay, so what we do now is you collect everything with dy by dx all on one side, everything else over on the other side. Now I can see here that's going to be a minus, so when that goes over, that will become plus, and that's going to become minus. And I'm going to make this 6y go to the front just so it looks nice, just so it's positive. So dy by dx minus 2x squared dy by dx would be equal to 4xy minus 3x squared. And then I'm going to factorise by dy by dx here. Now you get really quick at this in time. So dy by dx taken out as a factor, brackets 6y minus 2x squared is equal to 4xy minus 3x squared. And then you just literally plug that over, but you could have done that in one go. I tend to do it myself, where I take the factor out and think, right, what would be that bracket, and just divide by it straight away. But I wanted to show you what I'm doing properly in this video. So then we asked to do something as well. It said find the value at the point minus 2, minus 1. So at minus 2, minus 1, not a bad idea to write above it xy. So x is minus 2, y is minus 1. Literally just chuck it into there with brackets and you can't go wrong. So you just set them up straight away. I'll show you how easy it is. So 6 brackets and minus 2 brackets squared. Okay, so the first one is 4x, isn't it? So 4xy, so x is minus 2, y was minus 1. And then is x squared, so x was minus 2. And then coming down to the bottom, then it was y, so that's minus 1 there. And then it was x at the back, so minus 2 there. And it comes out as 2/7. So minus 2 minus 1, dy by dx equals 2/7. Okay. Next point. Now, I think number 4 is pretty tricky. Okay, so let's start a fresh page. Yeah, the reason why I thought number 4 was really tricky was they usually give us x and y, but they've given us x and dy by dx this time. So we're actually going to have to go and find out what y is at some point. And they've given you 10 marks there. And I got myself into a right faff the first time with this question, so be careful. This is a tough question. Okay. So it says find an expression for dy by dx by dt in terms of t. Now that bit's pretty simple. So 4a. So x was equal to 2t cubed. And the first bit wants me to find dt by dx, which is literally as simple as saying 6t squared. Okay? So from here, what do we have to do next? So part A done. Part B, find an expression for d2y by dx squared in terms of t, and hence show there's no value for t, which d2y by dx squared is equal to 2. Now that bit's not that bad. You have to learn this formula though. So d2y by dx squared is equal to d by dt, so you differentiate the differential, and then you times that by dt by dx, which effectively will cancel out these two dt's, d dy, d squared y, dx, dx squared. Okay, so from here, I need to differentiate the differential with respect to t, so that's going to be 2 plus 12t squared. So I'm going to say, therefore, d2y by dx squared is equal to, what did I just say? I said 2 plus 12t cubed, and then I need to times it by, now be careful, if we look back at this, it says dt by dx. I had dx by dt, so dt by dx would be equal to 1 over 6t squared. So 1 over 6t squared here. Okay, so that is going to basically be that divided by that. And I can see that they're all even numbers, so I'm going to divide each of these things by 2. So I'm going to get 1 plus 6t cubed all over 3t squared. Now that is actually as far as it will go, because there's no t in this bit here, I can't cancel that t, but what I could do if I wanted to do is, because this is all over one denominator, I could split it to being 1 over 3t squared plus 6t cubed over 3t squared. Now that would cancel quite a lot, wouldn't it? So 1 over 3t squared plus, so that's going to go to being 2, just 2t. So that's quite nice in some respects, especially if I needed to differentiate that again or do something. But it may just be a waste of time. You may prefer seeing it in that form there. It doesn't actually matter. They're the same thing. Okay? And then it's what did it want me to do part B? It said, and hence show there's no value for d2y by dx is equal to 2. Okay, so I just chucked that equal to 2. I'm going to go back to that very first version I wrote. So I'm going to say 2 equals, so I'm literally just replacing that for 2 and then putting that bit in. So 1 plus 6t cubed. So 1 plus 6t cubed over, I think I made a mistake here, haven't I? The differential, yeah, t squared. T squared. So this should have been t squared here, so that would have just been plus 2 by there. Plus 6t squared all over 3t squared. Okay, so bring that 3t round and you get an expression which can't possibly be true. Okay, you've got 6t squared is equal to 1 plus itself, which can't be true, because if you think of any number in the world, if you add 1 to it, it's not the number it was before. Okay, so literally I just make it, or here's another way of doing it, take the 6t over, 0 equals 1, because you just take away the 6t squared, say this is not true, as 0 does not equal 1, therefore no value of t will give d2y by dx squared equals 2. Okay? Right then, the part C. Now, I think the layout is the most important bit of this. Okay? So I'm going to say by here, the way that I normally set it up, x dx by dt, y dy by dt. Okay? Bear in mind, I don't actually know what either of these two things are. X was 2t cubed, and this was 6t squared. Okay. Let's have a look. So it says, given that y equals 10 when t equals 1, find expression for y in terms of t. Now, they gave us dy by dx straight away, but we usually use this formula. dt by dx times by dy by dt. Now let's sub in the information that we've got that we know that makes that already. So dy by dx was 2t plus 4t cubed. dt by dx was 1 over 6t squared times by dy by dt. Okay, so what I'm going to do now, that's effectively like divided by 6t squared here. I'm going to take that over and it's going to effectively become just times those things there. So I'm going to get 6, well, in fact actually let's solve it straight away. 6t squared times by 2t would be 12t cubed, and then this would be plus 24 t to the power of 5 would be equal to dy by dt. Now dy by dt, I now know is this thing here. I could say it's 12t cubed plus 24t to the power of 5. Now that is differentiation to work that way. And again, if I went that way, if I differentiate going this way, the inverse process of differentiation is integration. So I'm going to integrate that. So I'm going to put the power up by 1, so it can become t to the power of 4, and I'm going to divide by the new power. So 12 divided by 4 is 3. Again here, power up by 1, t to the power of 6, divide that by 6 is 4. But don't forget you plus a constant term there, because we integrate it. Okay? Now this is when I can use the information they told me, which was y equals 10 when t equals 1. So, therefore, y equals 3t to the power of 4 plus 4tx, t6, sorry, plus c, and we told that y was equal to 10 when t was equal to 1. Now, anything to any 1 to any power is always 1, so in some respects I didn't need to write it, but that's going to be 10, 3 plus 4 is 7, plus c, so c is equal to 3. Therefore, y equals 3t to the power of 4 plus 4t to the power of 6 plus 3. Okay. Next question, iterations. Now iterations are very, very, very easy as long as you know the trick that we talked about in class. So they've given me x0 is equal to 1, and they want me to find up to x4. And they want me to go to as far as 5 dp. Now all of these must go to 5 dp. You don't actually round them, this is properly rounded to 5 dp here, but they must all show at least 5 decimal places. If you don't do that, you'll lose a mark. Okay? Now x0 equals 1, so all you do is put in 1 equals. So 1 equals, and then you just set it up there, wherever you see an xn, you just press ands. So 3 over 1, not 1, sorry, ands plus 7. Okay? Now, all I have to do is keep pressing equals and it answers it for me. So it's root 6 divided by 4, and then it's 0.62777 ... to show it continues, so don't round that. Then it's 0.627136 ... and then it's, and this is the one I do actually round properly to 5 decimal places, 62716 to 5 dp. 2, 3, 4, 5. Yes. Okay. Now I prove that by taking upper and lower bounds. So I do f of. Now I treat that as 60. I've just put an imaginary 0 on the end, so it's not 6, it's 60. Take off 5, add on 5. So take off 5 will be 55, add on 5 will be 65. 55 will be my lower bound. So f of 627.155 equals, and f of 0.627165 equals. Now that goes into the original formula, so this one here. So I'm going to do x cubed, so 0.627155 cubed, plus 7 lots of 0.627, what was it, 627155 squared, take away 3. Now if it's equal to 0, one answer should be just below 0 and one answer should be just above 0, so I'm expecting to see a negative answer here. Lovely, negative 6.1. The fact it's in the standard form just tells you it's very, very, very close to 0. So I'm going to say equals minus 6.15 times 10 to the minus 5, and then change those to 6's. And then look, it's gone positive, so that's 3.8, no, it's not 3.81 times 10 to the minus 5. But it's not that minus that we care about, it doesn't matter. It's this minus here, minus then plus. So all you say is that as a change of sign, therefore alpha equals 0.62716 to 5 dp. Okay, that's like 5 marks. It's nuts. It's a lot of marks. Okay, so 6A, we are looking at the differentials here. Now you're going to be using product rule, quotient rule definitely, chain rule possibly. If it's hard, use chain rule. Okay. The first one is actually quite a hard one. I'm going to use the chain rule, so I'm going to say let u equal what the bracket is. So let u equal 5x cubed minus x. So y equals u to the power of 10. I differentiate this thing with respect to x, so it becomes 15x squared minus 1. I differentiate this thing with respect to u, which would be 10u to the power of 9. dy by dx would equal du by dx multiplied by dy by du, because it would cancel out the du's. So I'm literally just going to times those two answers together, so 15x squared minus 1 times by 10, but bear in mind u we said was this thing here, so we just chuck u in terms of x again. So 5x cubed minus x to the power of 9. Okay, and then I'm just going to make it look a bit nicer, so I'm going to put the 10 at the front and just put the two brackets touching. Like that. Okay, the rule that I've told you to try and get in your head is times by the power, and then times by the differential of the bracket and reduce the power of the bracket by 1. And that would have worked here, but it wasn't the nicest one in the world. And the same with this one, they weren't the nicest differentiation questions. So we've got sine minus 1x cubed, sine minus 1x cubed. So again, I'm going to let u equal x cubed, so y equals sine minus 1u. Okay, now this is where you'll want to use the formula booklets, certainly for the second bit, which I'm going to use now. I can do the first bit, it's 3x squared. Dy by du, I'm not certain on, so let me just check. Okay, so what is it? Sine minus 1. Okay, so there it is. Now they've just given it to me in terms of x, so I just need to change an x to a u. So 1 over the square root of 1 minus u squared. 1 over the square root of 1 minus u squared. So then I just times these two things together. So dy by dx. Now that times by that as a fraction, you just times the numerator. So it just becomes 3x squared times 1, which is 3x squared, all over the square root of 1 minus, now u was this thing here, was x cubed and then squared, so times by itself will be x to the power of 6. Okay, part C, product rule. We've already used the product rule very briefly in the implicit differentiation. So we've got x for ln 2x. I'm just going to write a rule here that I know that d by dx of ln x is 1 over x. That's a really important rule that we need to know. Now, this thing here is in terms of u dot v. So u is equal to x to the power of 4, v is equal to ln of 2x. So u dash would be equal to 4x cubed, v dash. So of ln x would just be 1 over x. Now, we've got a way of remembering that, which is the differential over the original. So the differential would be 2, over the original, which is 2x, and 2 over 2x just becomes 1 over 1x. But in terms of anything, ln to any just normal number of x, so like ln of 10x would just be 1 over x, so it goes 10 over 10x, which would cancel down to being 1 over x. It's just when this gets powers that we need to remember that differential over original, but it's worked quite nicely here as well. So product rule states that uv dash plus vu dash. So I have to basically just multiply across the diagonals. So I'm going to get y dash is equal to x to the power 4 times by 1 over x, and then plus 4x cubed times by ln of 2x. So that's going to become x cubed plus 4x cubed ln of 2x. And then in C3, we should always try and take out any factors if we can. So x cubed and x cubed in both. So it's going to be 1 plus ln of 2x. Okay? 4 ln 2x. Okay? And then part D, e to the 4x. These ones are quite fussy and they've chucked in the chain rule again. Plus 3 even to the power 6, which is equal to u over v. Okay? So u equals u dash equals, so u is equal to 4e to the 4x. So u dash is equal to 4e to the 4x. V is equal to this bracket here. Again. And then v dash is equal to, now it's the differential of the bracket, so that's 2 times by the power, so that's 12, and then the bracket you drop by a power. But if in doubt, chain rule it out. You can go and do the chain rule to go and prove that if you want to, okay? Now, the quotient rule. Now this is actually given in the exam, but slightly different terms the way I like to work with it, okay? But I will show you. So they've said here, they've done it in f of x notation. So they've said there, it's the derivative of the top function times by the original of the bottom, take away the top function times by the derivative of the bottom all over the derivative of the bottom squared. Okay? Now I like to write that, I remember the product rule, so if we look at the product rule up by here, where was it, this thing here, basically these two guys just flip around, and because they flip around, you just have to change it to a minus, that's how I remember it, all over the bottom one, so v squared. Okay? It's just the way I learned it, it's just stuck in my mind, but if you want to, you can actually call that f of x, that g of x, and then just use their notation, and then you're using the formula booklet, aren't you? Okay? So, from here, what have we got? We've got v u dash, so that's this diagonal here, so that's going to be 4e to the 4x, and then 2x plus 3 to the power 6, take away, and it's going to be this one times together, so it's going to be 12 times by e to the 4x, and then 2x plus 3 to the power of 5, all over this bracket here, but then squared, so that's going to change to a power of 12. Okay? Now, as I said before, we must cancel out. I can see loads of common stuff here. So 4, 12. So 4 goes into both those. E to the 4x, e to the 4x. Lovely, that comes out. And this whole bracket here, so you always just take the lowest power. So you're going to take out 4, e to the 4x, and then 2x plus 3 to the power of 5. So what do I need to make that? Take 3, I'll just get this, try and finish this off now. So I was factorising this thing here, and I said that you needed the lowest common, the highest common factor out of these ones. So 4 e to the 4x was in both, and then you take the one with the lowest power in, and that would leave me, to get this one, would be 2x plus 3 to the power of 1, and then minus, because that times by that would add up to give 6, and then minus 4 times what makes 12, 3, and that's it. The rest of that stuff is already there. So bracket goes round that, that's all over 2x plus 3 to the power of 12. Now, there's two things I'm noticing here. This bracket is on the top and the bottom, so I'm going to cancel that out there, cancel that, 5 and 12, we add and subtract, so that now become just to the power of 7 on the bottom. And then anything to the power of 1 is just itself, so it's 2x plus 3 minus 3, so they're going to cancel as well. So then finally, I'm going to expand that bracket, which times it by the 2x, so it's going to give me 8x e to the 4x all over 2x plus 3 to the power of 7. You know, that was a full-on question. That was not easy. Okay, let's look at the marks. What we're on? We're on 4 marks. So that you'll be picking up a lot of the marks for getting as far as this stage here. That'll probably only be worth 1 mark, those 2 lines there. So if you're getting into a fuss about that bit there, it's probably not that many marks. Okay, we'll have a look at it in class anyway properly. So the next question is integration. So that is the inverse process of differentiation. So it should be quite simple if you know your differentiation well. So let's start 7a. So we've got the integral of e to the 5x over 6 dx. Now we like e to the x because whenever you integrate it, what am I looking for here? You just leave it exactly the same. So it's going to say e to the 5x. Now you divide by the power. So you're going to divide by, or the differential, sorry, not by the power, divide by the differential of the power. So you're going to divide that by 5 over 6 plus c. And I'll neaten that up. When you divide by 5 over 6, it's like times by 6 over 5. So it's become e to the 5x over 6 all over 5 plus c. This is sort of a slightly neater version. Part B. Now, I'm not going to write it down like that. I'm going to write it into a bracket because I can't integrate things unless they're as indices. So it's going to be 8x plus 1 to the power of a third dx. So that is going to equal. Now it's going to equal exactly the same bracket, but the rules of integration are power up by 1, so it's going to become 4/3, divide by the new power, but also times by the differential of the bracket, plus c. I'm going to neaten that up. That 4 times by the 8 is 32, and that 3 I'm going to take up onto the top. So it's going to become 3, 8x plus 1 to the 4/3 all over 32. Okay. For part C, I've got sine. So this is where my front sheet comes into handy again. So sine integrates to minus cos. So let's remember that. Sine integrates to minus cos. And if I write down what the question is, it says sine bracket 1 minus x over 3 dx. So it's got to become minus cos to exactly the same thing. Okay? But just as I said before, the power goes up by 1, divide by the new power, and then times by the differential of the bracket. Well, there's no power here, so we don't have to worry about that, but you do need to divide by the differential of the bracket. So what is the differential of this? Well, it would actually be minus 1/3, and don't forget your plus c. Dividing by a third is like times by 3. Minus and a minus makes it plus, so it actually becomes positive. So it's 3 cos 1 minus x over 3 plus c. And then for D, this was actually part 1, 2, and 3. So this is really part B, but I'm just going to leave it as that. Now, we know to integrate things when you have limits that you sub in the numbers and you do the top number, take away the bottom number, and it gives the answer. They've told us what the answer is, okay? So we need to do that and set up an equation for it and solve that effectively, okay? So we're going to get the integral between a and 2 of 1 over 4x minus 1 dx. Now, if there's no power on the bottom here, we don't change that to just 4x to minus 1 to the power of minus 1, because that power will go up to 0, which would effectively be 1. It must have had something to become this thing. If it's ever got no power on the bottom, it always becomes ln. Okay. Now, technically, you should have mod signs here, but mod signs make things positive. The 2's positive, and we're told in the question that a is greater than 2, so we don't strictly need those mod signs there. You also divide by the differential of the bracket, so we need to divide this by 4. Now, this would then go into square brackets, and I'll put my limits in here, which is a and 2. So, I'm now going to sub into that to 4, and I'm going to just put brackets in now to make it easier. So for a, because I've subbed in a for x, minus 1 all over 4, take away ln of 4 lots of 2, so that's 8, take away 1 is 7, all over 4, equals, now I actually know from the question that equals 0.284. So it equals 0.284. So I'm just going to solve this now. So I'm going to take that over and add it, and then I'm going to times it by 4 to get ln of 4a minus 1. And in the calculator, I'll show you what I'm writing. So I'm going to write 0.284. I'm going to take this over first, so plus ln of 7, and then that divided by 4. comes to that. I'm then going to bring this divided by 4 over and times that by 4. So that becomes 3.0819 blah blah blah. I'm now going to take ln over, and that's going to leave me 4a minus 1 is equal to e to the power of 308,194. I'm going to put that into my calculator as e to the power of ans. And then I'm going to just try and solve in one go here. So I'm going to take over the minus 1 and plus 1. So I've now got that answer, and then I'm going to divide that by 4, which gives me 5.7 to 1 decimal place. And I'm assuming that's what they want to, look at all those zeros, it feels like it's too close to be lucky. And when it's said to 1 dp, I mean that's filling me with confidence. Okay, then, number 8, some mod signs. Okay, now the trick that you can do to make this really quick is, let me write out the question first. So mod of 3x plus 4 equals 2 mod minus 3. Now, I don't like the mod signs, okay? If they're brackets, it'd be easier. I'm going to change them into brackets. But to do that, once I must treat the mod sign as positive and once I must treat it as negative. But you only need to do it on one set of these, either this one or this one, and it will give you both solutions. You could go and do it where you take the positive this, the negative this, and the positive this, and the negative this, but they always end up working out to be exactly the same answers. So you only need to just choose one side. I always choose the one that's all encompassed within a mod sign. It's where I take the positive version of that and the negative version of that, and then you just change it to brackets. Okay, so I'm going to have, so for my positive version, I'm going to have 3x plus 4, where I just treat it exactly what it is equal to 2 brackets x minus 3. I'm going to expand those brackets to get 2x minus 6, and then I get x is equal to minus 10. And then my minus solution, I treat this to being the opposite signs of what they both are. So this will become minus 3x minus 4 is equal to 2 bracket x minus 3. So minus 3x minus 4 is equal to 2x minus 6. So then I'm going to get 2 on this side. I'm going to get 5x on this side. So 2/5 is equal to x here. Okay, done. The next one, we are on to our functions. So 9. And we are asked to do an inverse function. So we're given this thing here. So inverse functions are graphs that are reflected in this dotted line, which is y equals x. Okay, and it says find an expression for f minus 1 of x, and then write down the domain of that. Okay. So the way to do it is to change the f of x to y. So we get y equals 1 plus 2 over root 3x minus 5. So that's exactly the same thing as I've got there. Okay, but all I've done is change that to a y. We rearrange this now to make x the subject of the formula. So I'm going to get y minus 1 is equal to 2 over root 3x minus 5. I'm then going to take this over as a times, but then I'm going to bring this over as a divide. So I'm just literally going to swap those two. So 3x minus 5 is equal to 2 and then y minus 1. I'm then going to take the square root over where it will become squared. So it's going to become 2y minus 1, but all of that thing squared. I'm not going to actually expand that. I'm going to leave it as that, because otherwise it'll take me ages. And then I'm going to take the rest over in one go. So 2y minus 1 squared, and then it's plus 5, and then the whole thing is going to be divided by 3. And that is my f minus 1. But I change the y to an x, and that's just the rule. That's how you do it. It was quite nice this time because I didn't have to choose. Like if you took over a squared and made it square root, you have to choose if it's plus or negative due to the domain that you have. But we didn't need to worry about that. So all good with this one. So that's got me 4 marks, and then to get the domain of f minus 1. So it says find the domain of f minus 1. It's the range of this thing here. So I just need to sub in 7 and infinity into that, and then that will give me the range of f of x, which is also the domain of f minus 1 of x. So I'm going to say f bracket 7, and I'm subbing it right into that thing at the top, so that f of x thing. So it's going to be 1 plus 2 over root. So it's 3 times 7, which is 21, take away 5, which is 16. So 2 divided by root 16, what's that? 4, so it's 1.5, isn't it? And strictly speaking, shouldn't have 2 equals on one line, so I'll change that to an arrow. and then f of infinity. Now be careful here, as people just say, oh, it's always infinity. Not strictly true. It's going to be the square root of infinity is infinity, and then anything divided by infinity actually goes to 1. So the answer is 1. Okay. Sorry, anything divided by infinity is 0, so 1 plus 0 being 1. Now you have to write your domain in ascending order, so it's going to be 1, 1.5. We now look at 1. 1 belongs to infinity. Infinities always have rounded brackets, so that must be a rounded bracket there. 7, what sort of bracket did 7 have? 7 had a square bracket, so this must have a square bracket round here. Okay, so I would just say, therefore, f minus 1, f to the minus 1 of x domain is equal to brackets 1, 1.5. Okay, and finally, number 10, we've got some normal function now, composite functions. So f of x, so it says by considering g dash of x, show that it is an increasing function. Now g dash just means the differential of that. To do that, I need to rewrite g of x. So g of x as a power. Now, don't confuse what I was just saying about integration, where we wouldn't bring it up, become none. That's integration. We're differentiating, which is the reverse process. So this is effectively the chain rule if you want to use that. So I would times by the power of the bracket, I would reduce the power by 1, and I'd also times by the differential of the bracket. The differential of the bracket is 1, so nothing to worry about there. So I'm going to get minus 4 times by minus 1, so that's the power of the bracket. Then that bracket again, but you reduce it to minus 2, so reduce the power by 1. So we're going to get here positive 4 over x plus 1 squared is g dash of x. Now, what does it mean when it says it's an increasing function? Well, take g's range. So g's, not g's range, so g's domain here. It is minus infinity to minus 2. So if I chuck in any number between minus infinity and minus 2, what happens? Well, I'm going to get a positive number because any number squared is always positive. So I get a positive, and then divided by a positive, what does that give? Well, that always gives a positive number, doesn't it? Admittedly, it could be a very, very, very small positive number, but it's positive nonetheless. So therefore, we will always have a positive differential. So therefore the gradient's always going to be a number, hence it's always getting bigger, hence it's always an increasing function. So we have increasing function. So we have increasing function. Okay, so that's part A. Part B, find the range of g. So find the range of g. We want to sub in those numbers, so minus infinity and g of minus 2, not g dash now, back to this thing, okay, this original thing by here, okay, so it would be minus 4 over, and then it's going to be minus infinity and then plus 1. Now, as we just had before, minus infinity plus 1 is minus infinity, and if you divide anything by infinity, it is going to become 0, so that's 0. And then this one here would be minus 4 divided by minus 4, but divided by minus 2 plus 1. So that's actually going to be minus 1. Minus 4 divided by minus 1 is plus 4. Okay, so my range for g is 0, 4. 0 belonging to infinity, which was a round bracket, and then 2 was a round bracket anyway, so don't need to worry too much about the round brackets this time, both round brackets. C. Write down the domain and range of f of g. Okay, so you have to remember some rules, and if you check the Twitter page, there's a really, really good rule that's written up by Grace. So check that if you want to check the rules. So it is always the domain of the second letter. So f of g domain is simply just g's domain. So it equals minus infinity to minus 2. You don't need to write down in bracket g's domain like I'm about to. I'm just doing that for you, okay? G's domain. To work out the range of this thing, f of g range, you would sub in what g's range is, because g will chuck out these numbers between 0 and 4, and then we will sub those into the first letter. So we'll sub 0 to 4 into f. So I need to do f of 0 and I need to do f of 4. So I'm going to get, what am I going to get? F of 0, so I'm going to get root of 5, and I'm going to get, this one's going to be bigger, isn't it? 4 squared is 16, 16 plus 5 is root 21. Now, I would look at those numbers in the exam and think, oh, I've probably gone wrong there, but honestly, you haven't, I swear. I remember these answers from before. It is root 5 and root 21, okay? So you write it in ascending order. Do I need to worry about the brackets? No, they're all round brackets, so round brackets, lovely, okay? Part D, part 1 is, what have we got? It says, write down an expression for f of g of x. So f of g of x, now the best way to write this is just whack a bracket round the second thing, and then change it to f, and then just chuck in whatever g of x is. So g of x is this minus 4 over x plus 1. And then, wherever you see an x in f, you change it to this thing here. So big square root sign is x squared, so minus 4 over x plus 1 squared, and then plus 5. Okay. Now, what does it say there? It says, hence solve. Now, that is an expression. There's no need to further simplify that. I usually get myself a little bit fussed by trying to solve that, but that is an expression for it, okay? So for part 2, it says solve it equal to 3, fg of x. Just check as well, because I've seen them do this a couple of times, that they are in the same order. So they ask you to do that one, but switch the letters here. So just watch out for that. It's fine. They've kept it the same. Okay. So I'm now going to put that equal to 3. The first thing I'm going to do is take the square root over and square this to get 9. So 9 is equal to, in fact, actually, let's take this. If I take that over and square it and get 9, let's take this plus 5 over and take away 5 straight away. Now that is going to be equal to minus 4 x plus 1 squared. Now hold on. Don't try and square this yet, because what's 9 take away 5? It's 4. Take the squares over now, and it becomes plus or minus the square root of 4 is equal to minus 4 x plus 1. Okay, so we've got our two solutions here. So we're either going to have plus 2 or we're going to have minus 2. So here's my first solution. Minus 2 is equal to minus 4 over x plus 1. And then my other solution is 2 equals minus 4 over x plus 1. Okay, so I'm going to just solve both of those. I'm going to try and squeeze it in just by here. We'd switch those two, so it's going to become x plus 1 is equal to minus 4 divided by minus 2, which would be plus 2. Take over the plus 1 to be minus 1, so x would equal, I just had it then, x is equal to 1. And this one here, this would actually give a minus 2 solution, and then take over the plus 1, and x would be equal to minus 3. Okay, but you should be able to work that out yourself anyway. I know I haven't gone through it in detail, but you should be fine with that. If you're not, give me a shout and we'll go over it in class. Now, hold on, one of these solutions may not work. We're doing f of g. The second letter has to be its domain. F of g's domain is between minus infinity to minus 2. So 1 does not fit that, because domain is a posh word for the x values, range is a posh word for the y values. So it is not that one, as not in fg's domain. And that, I believe, is the end of the paper.